Hey people, welcome to Security, Privacy, Risk, Crypto, and FinTech. This is your host Shahid Sharif from Toronto, Canada, publishing my show every week on a Sunday. I have been in IT security, audit, risk, and compliance for over 20 years and since 2013 in blockchain and FinTech. Today I will be talking about self-sovereign identity. I will walk you through the evolution of identity systems and provide an overview of the self-sovereign or user-centric identity. Please subscribe to my channel on whichever medium you happen to be using. If you are on YouTube, don't forget to click on the bell icon to ensure you get notified of the latest show. Don't forget to share it with your friends and make sure you show your appreciation by liking on Facebook, hearts on SoundCloud, thumbs up on YouTube, and a review on Apple Podcast. Trust was something that was local and useful for establishing trust in a single domain. And the only issue with existing identity systems is that they are not trustworthy. Still, there is no good way to prove that you are a certain age, you have an account with a certain bank, etc. It is very difficult for someone else to vouch for you. Initially, identity was siloed, in which there was a single domain. Then came the federated identity. And now it is time for user-centric identity. This is what self-sovereign identity is. So when I talk about siloed identity, in early days when you logged onto a website, you had to have separate user ID and password for that particular site. So these were the initial days of the internet where you had Yahoo, the Microsoft, and back then AOL also existed, and CompuServe did too. But each of them had their own credential system. So you need to have a separate user ID and a password. Then came the era of Web 2.0, which is the time of the Facebook and the Googles, where people start using Facebook and Google a whole lot more. And as a result, Facebook decided to allow people to use their authentication mechanisms for other websites. So other websites included that capability in their registration and authentication mechanism. So when you went to a certain site, they said you can use your Facebook credentials or Google credentials for logging in, which was great for people because they just had to remember one credential. But the only issue with the federated identity was, again, it was centralized. It was owned by Facebook or Google or whichever organization that you were using, because right now there's lots of organizations that are allowing you to use their identity systems for authentication, like GitHub allows using it for different mechanisms as well. And right after that came the user-centric identity. So what is user-centric identity? So far, Facebook and Google have dominated that, but the problem is no one trusts Facebook. So no one really knows if the person who's claiming to be somebody on Facebook, they are really who they are, because people don't really provide their date of birth and some details properly on Facebook, and likewise on Google as well, and on other websites. So the idea that Facebook and Google started with was they could be used as identity systems, and that identity could be used by certain organizations to trust. As I said earlier, identity builds trust, and so far Facebook and Google have not provided that trust. So the whole idea about user-centric identity is that, or self-sovereign identity, is that the user is in control of their identity. It is open, it's flexible, it's interoperable and portable, it's viable and sustainable. The other piece about user-centric identity is also the fact that no one is controlling your identity for you. So right now, what happens is your Facebook ID or your social insurance number become your identifiers, or your phone number for that instance. And if someone can get to them, they can correlate that information with you wherever you're using them, and that becomes a huge risk as well. Same thing with health identification numbers as well. Somebody could use that to correlate to you, and that's why you might have issues. And this was a reason for the Equifax hack that happened. It exposed so much information about people, because there was one identifier for everybody, and that identifier had so many things linked to it. So that's why the existing identity system seems to be broken. One compromise and you're done. So the way the user-centric identity can be implemented, and the reason behind user-centric identity is, again, the user controls the identity in terms of what they want to share with the other party. Because right now, if you go to a bar, they want to check your certain ID, and most of the time is driver's license, to make sure that you are indeed over 18 years old. Likewise, when you go to a hotel, they want to check your passport or your driver's license to make sure that you are who you are claiming to be, and so forth. And the issue with this is, when you're sharing that identity with that individual, you might be sharing a whole lot more information than you're supposed to, because your driver's license, let's say we're talking about, it has your date of birth on it, your address on it, your height, your eye color, your name, obviously. And sometimes that individual, so let's say in case of you're visiting a bar, all they have to make sure is you are over 18 years old. So that individual does not need to know your date of birth or the exact date of birth. So what would happen with the user-centric identity would be, the workflow is going to be such that the barkeeper asks you to prove that you are indeed over 18, and you have this verifiable claim that you've had a third party sign for you, which just says you are over 18. It does not share the exact date of birth of yours with the bartender or barkeeper. So you just, on your phone, you say, share my verifiable claim with this individual. They look at the verifiable claim. It says, it has a picture on it, and it says, XYZ person is over 18 years old. Done, and that's it. So in that case, you have not shared more about yourself. You shared just enough information to provide that particular service. And some of the key properties of a verifiable claim are that they are decentralized and contextual. Anybody can be an issuer, owner, or a verifier. Verifier does not need to have any kind of relationship with the issuer, not commercial, contractual, or technical. Verifiers make their own trust decisions. Credential owner decides what credentials they want to carry around. So when we're talking about verifiers make their own trust decisions, so again, this is up to the verifier to trust what they want to trust. No overarching body is going to tell them that you will need to look at this or that, right? If an organization thinks they are happy with having a picture on that particular ID and some kind of a claim that you are of a certain age, if that's the information they want, then if that satisfies them, that is fine, right? Likewise, with the credential owner, you decide what credentials you want to carry around with you. So when you leave your home in the morning, in the wallet, you keep your credit card, your driver's license, and whatever you keep with yourself, right? But you decide through your experience what information different parties have requested of you over the period of years. So you just bring those with you, and you as a credential owner have decided what credentials you want to carry around. And the other piece about verifiable claims is that verifier does not need to have any kind of relationship with the issuer, not commercial, contractual, or technical. So how are verifiable claims implemented? So decentralized IDs are the new type of identifier for verifiable claims. Self-sovereign digital identity. DIDs are fully under control of the DID subject, independent from any centralized registry, identity provider, or certificate authority. And this is an excerpt from W3C, because they are the body who is standardizing the DIDs at this point of time. You can read more about the link I will provide at the end of the post. Some key characteristics of DIDs are string of digits, cryptonyms derived from elliptic curve private public keys. DID is written to the ledger. DIDs provide pairwise identifiers for every relationship to prevent correlation. DID descriptor objects link DIDs to public keys and endpoints. Verifiable claims allow third parties to provide identity owner with credentials they can use just like we do offline. Once the other system has your DID, they can look up your public key, take a nonce, sign it with their private key, send it to you, and then you can sign the nonce with their public key, and this way they can confirm that the person they are talking to is the person in control of the private keys. And the important piece over here is you can have as many DIDs as you want. So you will not have one DID for everything. So if you want to, let's say, share certain pieces of information with your bank. So you might have your social insurance number, your date of birth, and your name and address, right? So these are the 4 pieces you want to say. So it is basically a JSON file. You create that and you send it over, right? And this is what you decide to share. So what you can do is you can have a third party sign this for you, that they have verified this, and then you can take this information when you want to open a bank account. The bank also needs to have the system deployed in their environment, where if you're using a cell phone, you say, I want to open a bank account. The bank says, can you provide us this information? You say yes. So you consent. You provide that information to the bank. The bank goes, picks that information from a particular database, and this database can also be a blockchain. And then they look at it, and once they confirm, they say yes, verified, and then they can open your bank account. Likewise for telcos, same thing can happen, or wherever you want to use. That's why every DID can have private key. So what that means is, for the person who utilizes the system needs to manage multiple private keys. Managing private keys is another topic to talk about. I know it's going to get crazy because you might have a lot of DIDs for different purposes. And the beauty of the DID is the fact that if you lose one, it's not a big deal. You can create another one, and it does not directly link to you. So, and then the other idea is anybody can write a claim schema and write that claim. Key requirements. So any system that plans to implement self-sovereign identity has to implement following mandatory requirements. No visible data to network operators. So whoever is providing the network, they cannot see what data is going through them. since there's no central database, so you don't have a Equifax kind of a situation where they're storing all your credit history, your credit card information, and everything about you. If that gets compromised, it becomes a honeypot, and people want to attack it. So, with self-sovereign identities, you have your banking information with your bank, your telco information with the telco, and some other information elsewhere, right? And all you're doing is you are having them certify that particular information for you. You carry that information with you wherever you go, and if somebody needs it, you share that DID with the other party, right? And they will verify that signature, and accept that. Because it is distributed, there are no single points of failure. It allows total privacy, so no one's going to be able to see how many times you went to the bar, which bank did you open the account in, because it is a identifier. No one's logging that information. All they're doing is somebody signed off on that and somebody accepted it. There's some implementations right now that are implementing self-sovereign identity. Uport is using Ethereum blockchain. Blockstack is using Bitcoin blockchain. SecureKey is using Hyperledger Fabric blockchain. Sovereign is using Hyperledger Indy blockchain. So DIDs enable verifiable claims, and then you can use DIDs on blockchains. So what sits on the blockchain is the DID. Blockchain does not store any of your personal information, any of your date of birth and all that. All that's storing is a DID. So whenever somebody wants to talk to you, they look up your DID, they pick up your public key, sign with the private key, send it over to you, and then you do likewise. You sign, and then that's how you prove the authenticity. So the bottom line is current self-sovereign identity systems are still very crude. They're still missing some essential tooling, which will show up as current platforms evolve due to learning from implementations. So it is not something that is going to be mainstream pretty quickly. SecureKey is being used a lot in Canada. Uport, I've had Uport for a while now. I've never used it myself. And then there is Civic also has something, which again, there's not a lot of use for it. People have created them, but not a lot use for it. Sovereign is again one of those organizations which is providing self-sovereign identity as well in the US. They are working, I think, closely with Utah government, state of Utah, for issuing their birth certificates. The only one right now, I think, the only two that are really being used and have use cases are Sovereign in the US and SecureKey in Canada. So all the banks in Canada are onboarded to this thing. Even the telcos, I think, are also using SecureKey. And Sovereign, again, same kind of situation over there. They're going to provide the tooling. You can use it for whatever you want to use. So there's multiple uses of this technology. But again, the key is the user is in control of their identity, and that's where, if you want to sell your information and you have the consent, then no one's stopping you from doing that. This podcast is This podcast is produced by me, Shahid Sharif. Thank you for listening, and don't forget to subscribe on my Facebook, Twitter, SoundCloud, YouTube, and Apple Podcast. You can join my Facebook group for better interaction. The link is in the show notes below. Thank you, and have a nice day. Bye-bye. The bottom line is current self-sovereign identity systems are still very crude. They're still missing some essential tooling, which will show up as current platforms evolve due to learning from implementations. So it is not something that is mainstream pretty quickly. Secure key is being used a lot in Canada. Uport, I've had Uport for a while now. I've never used it myself. And then there is Civic also has something, which again, there's not a lot of use for it. People have created them, but not a lot use for it. Sovereign is again one of those organizations which is providing self-sovereign identity as well in the US. They are working, I think, closely with Utah government, state of Utah, for issuing their birth certificates. The only one right now, I think, the only two that are really being used and have use cases are Sovereign in the US and Secure Key in Canada. So all the banks in Canada are onboarded to this thing. Even the telcos, I think, are also using Secure Key. And Sovereign, again, same kind of situation over there. They're going to provide the tooling. You can use it for whatever you want to use. So there's multiple uses of this technology. But again, the key is the user is in control of their identity, and that's where, if you want to sell your information and you have the consent, then no one's stopping you from doing that. This podcast is produced by me, Shahid Sharif. Thank you for listening, and don't forget to subscribe on my Facebook, Twitter, SoundCloud, YouTube, and Apple Podcast. You can join my Facebook group for better interaction. The link is in the show notes below. Thank you, and have a nice day. Bye-bye.